Imagine stepping up to a desk, pressing a single power button, and looking at an ultra-thin, jaw-dropping piece of glass that instantly handles heavy industrial workloads without a single separate tower or cable cluttering your floor. For years, the professional desktop market has forced you into an annoying compromise. If you wanted elite, world-class computational power, you had to accept a chaotic mess of external monitors, dedicated graphics cards, and power cords drawing massive amounts of electricity. But deep inside Apple's restricted hardware laboratories, an engineering project codenamed H17C has completely torn up that old blueprint. Apple didn't just scale up a consumer computer. They re-engineered the very definition of an all-in-one workstation. This is the moment the machine designed for the world's most demanding creators makes a spectacular comeback. Welcome to the era of the Apple iMac Pro. If you think this is simply a larger version of the standard colorful consumer desktop, you are completely blind to what is happening beneath the chassis. The real story isn't about minor aesthetic changes or a slightly better screen. It is about an absolute monster of a machine featuring a breathtaking 32-inch visual workspace, an aggressive internal vapor chamber thermal system, and a next-generation silicon architecture designed to run heavy local intelligence models and native AAA development pipelines without dropping a single frame. Today, we are breaking down the internal kernel leaks, the secret manufacturing pipeline data, and the precise mechanical adjustments that are threatening to make expensive, separate tower setups completely irrelevant. If you want to know what happens when raw hardware power collides with pure, uncompromised industrial design, you need to hear exactly what this machine is carrying. The journey to reviving this legendary lineup begins with solving a massive engineering crisis that has plagued professional all-in-one computers for decades. Thermal physics. When you pack desktop-class processing cores behind a premium, high-resolution panel, the heat generated can easily degrade performance, leading to aggressive thermal throttling. To prevent this, Apple completely overhauled the internal architecture, ditching the razor-thin consumer design for a slightly deeper, beautifully structured chassis that turns the entire back of the computer into an advanced heat dissipation machine. Utilizing low-profile vapor chambers and custom-designed high-static pressure fans, the system moves massive amounts of air across the main logic board in near-total silence. This allows the internal processing cores to run at maximum clock speeds indefinitely, giving professionals sustained, peak performance through hours of heavy rendering without a single stutter. This thermal efficiency is critical because the silicon driving this computer is an absolute powerhouse. Built on an advanced, bleeding-edge 3nm process, the next-generation M5 Max architecture breaks free from traditional computing boundaries. Instead of separating the processor from the memory via a bottleneck data bus, this machine scales up Apple's unified memory architecture to unprecedented levels. This means the enormous graphics processing unit and the lightning-fast central processing unit share instant, direct access to a massive pool of high-bandwidth memory. When a developer or 3D artist loads a highly complex scene containing billions of polygons or massive textures, the data doesn't have to wait in a slow pipeline. The entire system architecture interacts with the data simultaneously, resulting in a smooth, real-time editing experience that feels like science fiction. This massive architectural pipeline